The following drawing, find the torque on the uniform 2-meter beam pivoted at a point O, pivoted at a point O. If the value of F1, F2, F3 is given and phi is given, and F2 is applied at the beam's center of mass. Okay, it's always a good idea if we can make the components of this F2. So perpendicular component to the beam is going to be F2 cosine of phi, and along the beam that component will be F2 sine of phi. Okay, what is the benefit? Because now if we want to find the net torque, then at point O, because of F3 there is no torque, right? Because there is no perpendicular distance, or R is 0. So because of F3 there is no torque, the torque is 0. Because of F2, the torque is only because of the perpendicular component, because the parallel component again is at 0 degree with respect to, because it's R cross F, right? So this, the angle between R and F is 0, so that's just 0. So it's only because of F2 cosine of phi. So the torque is going to be R cross F. What is R? Since this is at the center of mass, so this will be exactly half the length. So that is 2 meter, total is 2 meter, and it is at beam center of mass, so that's going to be 1 meter. So the torque is going to be F2 cosine of phi times 1 times sine of 90, because it is at 90 degrees. What is F2? 40. And what is phi? That is 30 degrees. So it's 40 cos 30 degree, which is and cos 30 is nothing but root 3 over 2. So that's going to be 20 root 3. And likewise, and remember the direction is really important. Now this force about this point is trying to rotate in clockwise sense, right? So I'll say that this is in clockwise sense. And F2, sorry, F1 on the contrary is trying to rotate like this about this point, so it is in counterclockwise sense. So the torque because of F1 is going to be F1 times this distance, right, which is nothing but 2 meters. And the angle is anyway 90 degrees, so we'll just say that is F1 times 2 times sine of 90 degree. F1 is nothing but, given that it's 25, then it's 2, sine 90 is 1, so this will come out as 50 in counterclockwise sense. So the net torque is definitely F1, the one towards the counterclockwise is a higher number, so the net torque is going to be 50 minus 20 root 3. Why minus? Because this is in counterclockwise, this is in clockwise, so they're in opposite directions. So this is towards counterclockwise because this is a bigger number. So all we have to do is grab our calculator and get this value, which will come out as 15.36. 15.36 Newton meter. This is the net torque. Thank you.